Have you ever pondered the immortality of stars or considered the role of dark matter in the universe? Let's embark on a cosmic journey and explore the life and death of stars. Stars, like all things, are not eternal. Their existence is a delicate balance of forces, a cosmic ballet of energy and matter. Born from the dense and turbulent regions of space, stars live their lives burning through their fuel in a process known as nuclear fusion. From the smallest red dwarf to the largest supergiant, all stars share this fiery heart, a nuclear furnace that powers their shine. But what happens when the fuel runs out? Well, stars are not exempt from the universal law of gravity. Devoid of the energy to resist it, they succumb to their own gravitational pull and collapse. This spectacular death gives birth to a new cosmic entity, a dense remnant of what once was a vibrant, shining star. Depending on the star's mass, this could be a white dwarf, a neutron star, or even a black hole, each with its own unique characteristics and mysteries to unravel. Our own star, the Sun, is no different. In about 5 billion years it will exhaust its hydrogen fuel. The Sun will then swell into a red giant, its outer layers reaching out to consume the inner planets, including our beloved Earth. This red giant phase will last for about 1 billion years, after which the Sun will shed its outer layers, leaving behind the core. This core will then cool and fade into a white dwarf, a dense ember surrounded by a cloud of cosmic ashes, the remnants of its former self. So, the stars we gaze upon at night, those distant points of light that have inspired countless stories, are not immortal. They are born, they live, and they die. And in their death, they give birth to new cosmic entities, continuing the grand cycle of the cosmos. In about 5 billion years, our own Sun will expand into a red giant, obliterating the inner planets, including Earth, before fading into a white dwarf surrounded by a cloud of cosmic ashes. Now, let's delve into the mysterious world of dark matter, which constitutes an estimated 85% of the universe. Dark matter, a term that feels both intriguing and elusive, is a puzzle that has baffled scientists for decades. It's like a cosmic phantom, invisible to our eyes and our instruments because it doesn't interact with light. This invisibility cloak extends to its interactions with ordinary matter too, the stuff that makes up you, me, the stars, and everything else we can see and touch. Ordinary matter is composed of familiar particles like protons, neutrons, and electrons. It's the stuff of stars, planets, moons, asteroids, comets, gas, dust, and even life itself. Yet, despite its ubiquity, ordinary matter is far outnumbered by dark matter, the unseen majority. So, how do we even know dark matter exists if we can't see it or touch it? The answer lies in gravity, the universal force that even dark matter can't hide from. Scientists can infer the presence of dark matter because it bends and warps space, affecting the motion of galaxies and stars. It's like seeing the water ripple around a submerged rock. You can't see the rock, but you know it's there. Now here's where things get really interesting. While it's clear that dark matter doesn't interact much with ordinary matter, scientists aren't sure if dark matter interacts with itself. To understand what this means, consider that every particle of ordinary matter has an antimatter twin. When matter and antimatter meet, they annihilate each other, releasing energy. Could a similar process be happening in the dark sector? Despite these questions, what's certain is that interactions between dark matter and ordinary matter are rare and weak. In fact, scientists believe that we've yet to detect such an interaction. But who knows what secrets the dark universe is yet to reveal? While interactions between dark matter and ordinary matter are rare and weak, scientists believe they have yet to detect such an interaction. With all this in mind, could there be a way for stars, including our Sun, to become immortal? Let's dive into the cosmic tug-of-war. Main sequence stars burn hydrogen in nuclear fusion processes. This creates helium, which is responsible for most of the star's energy and an outward radiation pressure. This pressure balances the inward push of the star's own gravitational forces, keeping stars in a stable equilibrium for millions or even billions of years. But what if stars could use dark matter as fuel, particularly in regions of the universe where the density of dark matter is very high? Picture it, stars feeding on this elusive substance, extending their existence beyond what we thought possible. Research team leader Isabel John puts it this way: stars need very large amounts of dark matter to efficiently replace fusion. While the Sun may not be immortal, The idea of stars feeding on dark matter to extend their lifetimes is an intriguing possibility that continues to challenge our understanding of the universe.